Hello, my name is Eileen Jin from the University of Texas at Austin, and this summer of 2026, I am participating in the REU program at the University of Texas at Dallas. My project will be covering AI image detectors, and I will be investigating their usability, limitations, as well as the effects they have in legal situations and in artwork as well. So for my abstract, or basically a summary of my project, over recent years, since around 2021, 2022, it's evident that artificial intelligence has continued to improve by the day. And with great improvements also comes great risk. And because of the rapid changes that have been made in the AI community, there have been concerns regarding the negative impacts as well. So, for example, with generative AI being such a large aspect of artificial intelligence in general, there have been new legal concerns that have been introduced. There is the possibility of using AI generated media to commit crimes and other things as well. For example, this media can be utilized to falsify evidence in court and imitate people to use for scams, which is called deepfaking. Examples of this include using someone's relative's voice in a phone call to ask for money, and the person on the receiving end might not know any better, and they would hand the money over to the scammer, and obviously this reflects the negative aspects of such generative AI. But of course, this is not the only harmful effect that has come with the rise of AI. In the art community, there have been instances where such online spaces encourage scamming. So artists will use AI to generate artworks and claim it as their own, and this creates distrust within the community. And because of this, I have decided to undertake a project that will analyze and compare the effectiveness of current AI detectors to hopefully try and mitigate such negative aspects of generative AI. And along with my investigation, I hope to apply my findings to suggest possible improvements in both photography and in artworks. So there were a few research questions that I proposed. The first one being, how do various types of modern AI image detectors perform against AI generated photos? So as I mentioned before, AI is always evolving, and so obviously in order to keep up with the rapidly changing AI models, detectors must be able to evolve just as quickly. And so I will be investigating just how well detectors hold up against modern AI models. And for my second question, how do AI image detectors perform against AI generated photography in comparison to AI generated artwork? So, as I mentioned previously, I will be investigating two different types of media, photography and artwork, because I myself am concerned with both aspects, being an artist myself, as well as a computer science major. And then third, which AI image detecting techniques are reliable against AI generated photos? So there are a variety of techniques that different detectors may implement to try and detect AI within images. And so I will be testing a few detectors that implement different techniques in order to hopefully see which technique is the best and which techniques are not as reliable. So just to touch up a little on related works in previous studies. So I read a few papers, and there have been investigations conducted that are concerned with this topic. And after reading a few papers, I noticed some common themes throughout all the works, so I'm going to talk about them a little bit. So the first one is techniques used in detecting AI-generated media. And some techniques include watermark-based detection, diffusion purification, as well as detecting noticeable AI artifacts within the image. For watermark-based detection, generative AI usually leaves behind a hidden watermark in their images, and using detection methods, it is possible to decipher such watermark and therefore label the image as AI generated, as well as noise detection, which has part to do with diffusion purification. It is possible to purify the image and classify whether it is AI or not based on the noise patterns. As for the second theme, models, this applies to both AI models as well as the detector models. Generative AI comes in many different forms, and the more recently evolved ones are getting a lot better at imitating man-made photos. And the model I will be using to generate the AI pieces is ChatGPT, which is also rapidly evolving. And to counter this, sometimes there are detectors that use artifact-based detection, in which they detect things that seem out of place in AI-generated images. For example, if there is an AI-generated person, the piece might have missing fingers or extra fingers, which can be used by the detector to classify the image as AI generated. And then the third theme is generalization. So a lot of papers have come to conclude that although detectors are improving, they lack generalization. And so with a big enough data set, it is extremely difficult for detectors to achieve 100% accuracy in detecting AI media. However, there have been possible improvements proposed by previous studies that talk about increasing resilience by increasing the data set, as well as other general improvements that I will touch upon later in the presentation. So after talking a little bit about what previous studies have done, now I will touch up a little on the uniqueness of my research project. So although previous publications have touched on a variety of topics to do with AI-generated media and AI image detectors, my project is unique in that I will be testing two different types of media. So instead of focusing purely on photography, I am also implementing artwork in my project, because this is something personal to me as an artist, and therefore my sample pool is relatively unique in comparison to previous works. And obviously, I hope to propose improvements for both photography and artworks in terms of detecting AI generated photos. So before I began my research, I did come up with a hypothesis on what I believe to be the result. So based on previous studies, it is evident that AI image detectors rarely ever achieve 100% accuracy when detecting AI-generated media. And therefore, we can conclude from this that detectors still need significant improvements in order to keep up with the rapidly evolving AI models. And because of these constant developments behind generative AI, my guess was that AI artworks would be more easily identifiable by the detectors because more artifacts tend to appear in generating artwork. So if you have ever searched up like any types of digital art, it is common that these art pieces sometimes have, like as I was talking about before, noticeable artifacts such as like weird hair formation, missing fingers, extra fingers, or like things such as the pose of the person is not quite correct. And these things can be easily picked up by detectors that revolve around trying to identify such artifacts. So from my theoretical overview, these are the detectors I have chosen to test my data data pool on, and each detector exhibits a unique detection method, which is very important because I am trying to see which method is the most effective and which methods are not as effective. So for my first detector, pick detect, it relies on texture and pattern inconsistencies. So a lot of what I was talking about previously, the artifact-based detection. Site engine, however, it relies on type detection and pixel content. So it analyzes something deeper than just purely the surface level, like textures and patterns. And then truth scan actually analyzes the format of the image, which is metadata, as well as noise patterns, which is the underlying pattern within the image itself. So a quick look into the timeline of my project. First, I will collect the sample, which will be my data pool, and then I will test the sample within the 3 detectors that I've selected. Then I'll record my observations, and then finally summarize my findings. So for my methodology, a closer look with more details, my sample size will be 40 images with 10 AI-generated artworks, 10 real artworks, 10 AI-generated photos, and then 10 real photos. And in order to AI generate these pictures, I will be prompting ChatGPT to recreate an image. The prompt will be the same every time to assume consistency. I will only be using ChatGPT to, again, assume consistency. And then after I've successfully AI generated all of the images, I'll download them all and then I'll run all 40 images through each detector. So just a few additional details before we get into the results. For the sample pool, 2 of the artworks will be digital pieces drawn by me to test the extent to which metadata affects detection accuracy. And then the sample pool will be diverse in terms of content. For example, there will be black and white photos, there will be color photos, there will be photos with different subjects such as people, landscapes, animals, and so on. And then for artworks, there will be paintings of people as well as abstract artworks. And then finally, all of the photographs will be of the public domain to avoid any copyright issues. And then for detector details, all 3 detectors will be performing AI identification utilizing the 3 different methods I touched upon previously. So moving on to the results. For detector 1 pick detect, which used texture and pattern inconsistencies as its detection method, when testing artwork, it did really well when detecting whether the human created works were human created or AI generated. Confidence level was pretty high as well, but then when it came to detecting the AI works, it mistakenly categorized the majority of them as human created when it was actually AI generated, and confidence levels were relatively high as well, which means obviously there is a little issue with this detection method because there were way too many false classifications. And then moving on to the photographs for pick detect as well. And here I ran into a different problem where sometimes it would say that it was uncertain about whether the photograph was human made or AI generated. And obviously we don't want this in a detector because uncertainty is as bad as being incorrect. And as well as the AI generated images here on the right, a lot of them were misclassified as human created when they were actually AI generated. So for a quick summary of the results from pick detect, it's not looking so good. For the accuracy when trying to detect real art from AI art, pick detect only scored 55%, and for photograph accuracy it only scored 40%. And do note that if the detector is uncertain about a result, then it is counted as incorrect. So from this table, we can slowly start to assume that using texture and pattern inconsistencies to try and detect AI for this particular sample pool is not as reliable because there were a lot of false negatives reported where AI was not detected, but the image actually was AI. For artworks, 9 out of the 20 were detected as so, and for photographs, 8 out of the 20 were not correctly identified as AI generated. For a Detector 2 site engine, its detection method was utilizing pixel content and type detection. And when testing artwork, there was a noticeable improvement in the accuracy rates. So they only incorrectly identified one image as AI generated. Confidence levels were relatively high as well. And for the actual AI generated images, it correctly identified all of them as AI generated. And then for testing the photographs, it actually correctly identified every single photograph as human created when it was actually human created, and AI generated when the image was AI generated. Again, confidence levels were pretty high as well. And for a brief summary of SciEngine's results, there is a large noticeable improvement where it scored a 95% accuracy in art and 100% accuracy in photographs. And among the table, it only incorrectly identified one artwork as AI when the artwork actually wasn't AI. And then moving on to the last detector, TruthScan, which uses metadata and noise patterns as its detection method. Once again, it performed relatively well. The confidence levels were a little bit lower, and it incorrectly identified one piece, but for the most part, most of the images were correctly identified. And then same goes for the photographs. Each and every single photograph was correctly identified by TruthScan. And then once again, a quick summary of TruthScan's results. It scored a 95% accuracy in identifying art and 100% accuracy in identifying photography. And once again, the results are similar to SciEngine, where there was only one false positive reported in the artworks category where it detected AI, but the artwork actually was not AI. So for the overall results, I made 3 graphs to try and visualize each detector side by side. And so once again, a reminder of what true positive, true negatives, and false negatives mean in this context. Both SciEngine and TruthScan had more reliable results because they had no false negatives and one false positive each. However, PicDetect performed poorly against the other two because it would often incorrectly classify AI generated media as human created. And so for key findings as well as a reflection of my project, in addition to its low accuracy rate, PicDetect's problem with uncertainty only magnified its unreliability. So a problem that the other two detectors did not have was being uncertain about whether an image was AI generated or human created, but PicDetect did have this problem. And so, based on this, artifact-based detection will likely only decrease in reliability as generative AI develops greater proficiency in mimicking man-made creations. And then lastly, even with a small sample size, it's evident that utilizing metadata, pixel content, and noise detection are more reliable ways to detect AI-generated images across both types of media. And so, overall, both artworks and photographs were able to be somewhat reliably detected by the methods that I just mentioned. And I actually proved my original hypothesis wrong, as originally I thought that artifact-based detection would be superior in terms of detecting AI-generated works, especially in artworks. However, this was proven wrong because I mistakenly undermined the current capabilities of AI and how far they've evolved in mimicking man-made creations. And as for the limitations of my project and possible improvements that I could make for the detectors, limitations include that my sample size was very small with only 40 images. And obviously, because of this, I cannot generalize the results across all types of data. Obviously, more variety in content can also be introduced to the data sample. So even though I tried to introduce variety by having black and white photos, color photos, and different subjects in them, obviously there is always improvements to be made in terms of variety. And then finally, I only tested 3 detectors and therefore only 3 different types of methods in detecting AI. And this could obviously be improved, and the results could be generalized if more detectors were tested. And the possible improvements that could be made for these detectors based on my findings is to update data sets to train detectors on, since AI models are so rapidly improving. As well as now, I understand that maybe deviating from artifact-based detection is the best way to go because of how rapidly generative AI is evolving. And then finally, implementing hybrid detection methods could be the go-to way because, as my results show, there are multiple different detection methods that prove to be reliable, and perhaps combining them could yield better results. As for future research and plans, if I were to extend this project, I could expand the sample size to maybe hundreds or even thousands of images by having a large database, and as well as maybe incorporating more of my own artwork, digital artwork, in order to test metadata detectors. And then, obviously, as I mentioned previously, testing more detectors could also help because incorporating new detection methods could help and investigate which methods are most reliable, as well as repeating the same methods to yield higher confidence values is also helpful as well. And then extending the project to account for robustness, so alteration of images, post-production changes. I could also take that into account in improving my project. So thank you very much for listening to my presentation. And of course, special thanks to Professor Eric Wong and our mentors for this wonderful opportunity and hosting this REU. And lastly, here are my references for the presentation.